All right, so let's take a look at an example where we can use all this information. So here I've got two triangles, and it states at the top that these two figures are similar. So I know that they're the same shape, just different sizes. And what we're looking for here is some of the missing information. For example, this side is missing information, and so is this side. And so what we can do is we can put our understanding of similarity to use. So first thing we want to do is we want to take a look and figure out, well, if they're similar triangles, then they have corresponding sides. And so what are those corresponding or matching sides? Well, here I've got a right angle. And so as I can see, they're not in the same place because I think what's happened here is this triangle's been turned. So they took it and rotated it 90 degrees counterclockwise. So that would mean that the 9 units on this side correspond to the measurement of 12 units on the larger one. Which would then mean that this question mark here, which I'll just box it out, should correspond to this 16 units over here. And of course that means that this 15 units, which I'll circle, corresponds to this missing side here. So what we discovered was that with similar triangles that all three sides, if I pair them up, this one, this pair, and this pair, they should all work out to the same scale factor or ratio. So the first thing I need to do is I need to find the complete set. So here, if I look, the boxed pair, it's not a complete pair of information. We're missing this one. The circled one, we're missing this one. The only one we have a complete information on is this pair, these corresponding sides. And like we've been doing, what we want to do is we're going to make a ratio out of those where I'm going to compare the image to the original. In other words, the new figure over the old figure. So 12 to 9, which if I reduce that down is 4/3. And if I want to go further, that means 1 1/3. So that's the scale factor. This is the scale factor of these two pictures, that this new image is 1 1/3 times larger than the original. And so just something to note, what we did was we did the new figure compared to the old figure. Something to pay attention to, because if we did it backwards, it would be 3/4, and this is definitely not 3/4 as small as this one. All right, so now how do we use that to find these two pieces? Well, what we can do is we can set up a proportion. Now I'm going to go back a step. I'm going to use the 4/3 because for proportions it's easier if we're using improper fractions and not mixed numbers. But let's say I'm looking for this box set. So, and instead of a question mark, let's call this x. So the way I'd set up that ratio is new figure over the old one, or the image over the pre-image. So it'd be 16 over x. And with similarity, it says that this ratio should be the same as the ratio that we got from the other side, which is 4/3. So I can say, well, 16 over x is equal to 4/3. And these are some pretty nice compatible numbers, so you might have figured it out already. But I'm going to cross multiply to figure it out. So here I get 4x equals 16 times 3, which I believe is 48. Divide both sides by 4. X equals 12. So this side is 12 units long. All right, and now I can do the same thing with our last set. 15 and question mark, we'll call this y. Okay, so new measurement over the old one. So we're going to do y over 15. And that should have the same ratio as this one, 4/3. So compare that to 4/3, set up a proportion, and then solve. So again, cross multiply. We get 3y equals 15 times 4, which I believe is 60. Divide by 3. Y equals 20. So that means this one has a measurement of 20 units. And of course, we're imagining that this all didn't take place on graph paper because we could have just counted the squares. So without the graph paper behind it, this would be the way we would use similarity to our advantage to find missing information about two similar figures.